Okay, we're going to continue on with the chemistry part of biology, which I know sounds a little weird, but really you have to have one. You can't have one without the other. Okay, so we were talking about electrons, and remember electrons are those little speedy things that orbit around the nucleus. And they need energy levels. They have levels at where they're at, and they stay there, and unless you do something to them, they're not going to move from there. Well, when they're in their lowest energy level, they have what they call potential energy. It's the energy of them in their regular location. Now, if you want to get some energy from them, you have to do something to cause a change in that energy. Energy, or electrons, excuse me, of atoms have different amounts of potential energy depending on the atom that it is. Usually the bigger it is, the more potential energy it has. And so you can release that energy when you do various things like chemical reactions. Okay, so the potential energy, or the place that you find electrons, their energy level, or another name for it is an electron shell. And it's basically an orbit where you find electrons. And the thing about electrons, they always want to go to the lowest energy level. Okay, they'll feel the lowest energy level before they go to the next level and to the next level. When you start moving around between energy levels, then you're going to get some energy released, and some various things are going to happen with your atom. And here it shows you, like if this is the nucleus, the first energy level, that's the first shell, that's the lowest energy level. This one has to be filled before this one has electrons in it, and then this one has to be filled before this one. Well, sometimes what happens now, and if you've ever done a flame test, you know what I'm talking about. When you add energy, these guys, they get excited, they absorb the energy, and they jump up. And they can only go from like here to here or here to here. They can only be in the energy levels. They can't hang out in the middle. But anyway, when they absorb that energy and jump up, when they go back where they want to be, then they give off energy. And usually, like I said, when you're doing a flame test, that energy would be a color. It would be a certain wavelength. And that's how we can identify certain elements, by the color that they give off. Here they're showing a ball bouncing down and how it's gaining energy. Well, kind of the same thing. But again, electrons like to be in the lowest energy level. If you add energy to them, they bump up, and they'll stay there for a little while, but eventually they'll go back down to where they're supposed to go. And when they do that, they give off energy. Okay, so when you're talking about the chemical behavior of an atom, and when I say chemical behavior, I mean, what does it react with? What will it produce if it reacts with air, or if you put it in water, or if you add an acid to it, that kind of stuff. The behavior of an atom really depends on those electrons and where they're at in those shells. The electrons are what cause elements to combine to form compounds. Okay, so when you're talking about making new substances, making compounds, that's what you're looking at, is the chemical behavior of the elements that make it up. Okay, the periodic table will show you this electron distribution. If you look, there's only two electrons in the first row. I mean, two elements, excuse me. So we have one in the first and we have two in the second. Now, when you get to the second shell, the second row, we add another layer. And again, like lithium's atomic number is 3, so it has 3 electrons. So the 2 go in the first, and then you got 1 in the second. Beryllium has 4, so you got 2 in the first, and then you got 2 in the second. And they get up to this next energy level needs to have 8. The first one can only hold 2, but after that, all the energy levels hold 8. That's when they're full. Okay, so we talked about the noble gases a little bit. I don't know if you've heard of them, but these are the stuck-up elements. They don't react with anything. The reason why they don't react with anything is they're already full. They got the maximum amount of electrons to fill their shells. They don't need anything. If you go down to fluorine, fluorine has 7. It needs one more, just one more to be stable. So, oops, sorry. So fluorine is very, very, very reactive. It just wants that one electron, and then it'll be good. Well, lithium over here only has 1. So if I get rid of this level, give them this 1, then I go back down to where I'm stable. So lithium and all of these guys in the first row, or column, I should say, that's a group, they are very, very active too, because they only got 1. So pick up 7 or get rid of 1, they're going to get rid of 1. So the metals like to give up their electrons. The non-metals like to take them in because they've got more. They're looking for a few more. These guys only got a few. They're willing to give them up. Okay, and again, here's showing your helium. When you look at a periodic table, there's the atomic number I was talking about. Here's their mass. This is the protons and neutrons added together. The symbol, and usually they have the name in there too. If you want to do the electron, it only has 2 electrons, so you'd have 2 in the first shell. And they just go in order. There's the first shell. There's your second shell. You know, 1, 2, 3, 4, and it goes on. These guys, again, you're adding another shell, so it's the same number, 1, 2, 3, 4, and it's actually the group number that they're in. We're determining how many electrons they have on the outside. Those are called valence electrons. Valence electrons are the ones that react to produce more stuff. Okay, and again, this is more just the same stuff. Nitrogen and phosphorus are in the same column. They got 5. He has 5. He's got more electrons, but these are inner shell electrons. They're not the ones that are involved in producing new compounds. They don't react. It's just the very outside ones. And again, those are the valence electrons. Okay. Oh, I just said that. Valence electrons are the one in the outermost. Okay. So it's 1 to 8. And they're the ones that are involved in forming compounds. They're the ones that react. They're the ones that form bonds. Okay. And the chemical behavior of those atoms is determined by the valence electrons. Like the first row, those guys are super, super reactive because they only got 1 to get rid of. And the 7th row, they're super, super reactive because they only need 1. But when you get in the middle, like carbon has 4. What do I do? Give up 4, take in 4. It's not very reactive because it doesn't have to worry about it. It's not, you know, this 1 or get 1. It's 4. We're in the middle. Okay. So they want to have 8, except for hydrogen and helium. They only need 2. But all the rest of the elements, they need 8. 8 is the magic number. So they look for 8 valence electrons, and once they have 8, then they're chemically inert. In other words, they're not going to react anymore. Okay, so another name for this place where you find electrons is it's called an orbital. The thing to remember is when we draw electrons and when we draw atoms, they're flat, and they're not flat. They're 3-dimensional. So they have what they call an orbit or an orbital. An orbital is a place where you find electrons, and every orbital holds 2. Okay, every electron shell has a specific number. Like the first two electrons are in the first orbital, and then the next 6 are in the next one. And I'm not going to get overly into this. If you take chemistry, we hit this hard, but just the thing to remember is an orbital is where you find electrons. Okay, this is what they'd look like. So in this orbital, this s orbital, you'll find 2 electrons. In this one, you'll find 2. This one has 1, 2, 3 orbitals put together, so there'll be 2 in this one, 2 in this one, and 2 in this one. So there'll be 6 orbitals, okay? And when you put them all together, they kind of look something like that. But again, when we draw them, they look like this because we draw flat. But atoms aren't flat. They're 3-dimensional, okay? So again, you can see where that's how we would draw it. This is more of what it would look like. But again, because they're not flat, they're 3-dimensional. But the big thing to remember is an orbital is a place where you find electrons, and every orbital has 2 electrons. It can have 1, but the max it can have is 2. I should say it that way. Okay, so when we have, when we're going to form a bond, okay, there's 2 different types of bonds we can end up with. We can end up where we transfer electrons, or we can end up where they share electrons. They'll do either or, whatever it's easiest for it to perform a bond. Okay, so when you don't have the right amount, when you don't have 8, they're going to do something to get 8. Okay, they're going to react and react and react until they get 8. Okay, and once they get 8, they form a chemical bond. Okay, so like I said, lithium has to give up 1, it gives it to fluorine. So the bond between lithium and fluorine is found once lithium gives its 1 electron to fluorine. Now fluorine has 8, and lithium can drop that whole outer shell and go to the lower one, and that one's full. Okay, so a chemical bond is going to form because of these electrons either transferring them, or they actually can share them too. Okay, when they share them, like I was saying, carbon has 4. Carbon's not going to give up 4. It's not going to pick up 4. Instead, what it'll form bonds with other substances so that it shares 4 more. So it'll have 4 of its own, and it'll share 4, and then they have to stick together because they're sharing them. That's a molecule, and that's a covalent bond. Covalent bond, they're sharing their electrons, okay? So they share their electrons to make a stable compound. All right, here they're showing hydrogen. Hydrogen each has one, it needs two. So what it'll do is the two guys will hang together. You have your two nuclei, each with one proton, and then you'll have two electrons in here. Great. That they'll stick together and they'll form a molecule. Okay? So if they share electrons, it forms a molecule. If they transfer electrons, it's called ions. Okay? So a molecule is two or more atoms held together by covalent bonds. Okay? You can have a single covalent bond where they share one pair. They can share double, or they can even, oops, didn't even put that in there. They can actually share up to 3 pairs of electrons, and that's called a triple bond. That's the most. There's no thing as sharing 4 and a quadruple bond, I guess it would be. That doesn't exist. But a molecule, you can either share one pair of electrons, you can share 2 pairs of electrons, or you can share 3 pairs of electrons. Okay? And they do that if they need to make sure that everybody has 8. Okay, so they'll do what they need to do in order for everybody to have 8. And again, the most common is a single bond, but there's a lot of double bonds, and there's actually triple bonds as well. Okay, the way you would draw it if you were doing hydrogen, hydrogen's molecular formula is H2. There's 2 hydrogen together. This, excuse me, this would represent a bond. 1 dash represents 2 electrons. Okay, here's some other ones. We have hydrogen. See, now oxygen is one of those that has to have a double bond. In order to get 8 around both, they have to share 4 electrons. Water, we've got water with oxygen and it's 2 hydrogen. And then here's methane. Methane, you got carbon in the middle, and carbon has 4, and then each hydrogen has 1, so they situate themselves, and now you see carbon has 8, and then each hydrogen has 2. Hydrogen only needs 2, everybody else needs 8. Okay? That's how you form what they call a covalent bond. They share the electrons, and the magic number is 8. Okay? All right. Again, here's just, there's different ways of representing it. There's, get out of here. Sorry, dogs. H2 is its formula. This is how you would draw, draw the electrons, and you can do it. This is called the Lewis dot. These two equal each other, so 1 dash equals 2 dots. Here's oxygen, water. I went through all of these already. So, and again, you can see the difference, the dots versus the dashes. 1 dash is 2 dots. But you're representing where the electrons are being shared. Okay, covalent bonds can form between atoms of the same element or different. It doesn't matter. They'll, like 2 oxygen will form together, 2 hydrogen, 2 nitrogen, like all the diatomic. But you got carbon and hydrogen, you got oxygen and hydrogen, you got nitrogen, you got all kinds of different forms that you can. So the combination, the compound is a combination of all those elements. And again, the bonding capacity is, is the atom's valence. They call that, but really the bonding capacity, like if you had carbon, which has 4, its bonding capacity is also 4 because it needs 4 more. Nitrogen has 5 electrons around its outside. Its bonding capacity is 3. It needs 3 more. Okay. Atoms in a molecule attract electrons. They can either have a really strong attraction or they can be like, maybe. Okay. The way you can tell is what they call electronegativity. And electronegativity is how much does that atom really want an electron? So like those guys with 7 that are only looking for 1, they really have a strong electronegativity. They really, really, really want that 1 electron and then they're stable. When you get to the guys in the middle, they don't really. Maybe you can give me, I'm going to share anyway, so I'm not that strong of electronegativity. So what you end up having is the differences cause what molecules, what they call are a polar molecule. You have a positive end and a negative end. Even though they're sharing the electrons, they'll end up with these positive ends and negative ends. And the most famous and the one that has the most polar properties, if you want to call it that, is water. Water is a great polar compound. It's the reason why water dissolves so many things, and it's so versatile. It's because it has a polar. And really what it means is that they're more attracted to the oxygen than they are the hydrogen, so you end up with a positive end and a negative end. It ends up with poles, and that's why they call it polar. Okay, we're just about done with our time now, so we're going to quit there. We'll talk about nonpolar bonds when we start the next section after you're done with your assignment. So we'll see you soon.